In this video, we are going to add an axle to the tower so that we can attach the lower arm that already has the gear connected. There are shaft collars on the outside. Actually, on this side, we're going to use a metal one, not the friction one. Spacers here and here. And then we're also going to add the top arm and the pieces of the gear that we need here. A spacer, a gear, spacer, and another spacer. Now here we're going to use a single gear instead of the high strength one for 1/4 inch axles with an insert. We'll just do the single. So in Inventor, let's start with the lower arm. I'm going to place, I need a 4-inch axle or shaft. We're going to put that near where it goes. Also going to need to get a 1/8 inch spacer, and I might as well grab the metal shaft collar while I'm there. Put those nearby. Okay, to put the shaft insert constraint is what I need. I go from here to that edge. I'm going to switch the solution and give it an offset, actually -1. And actually I don't want to switch the solution, it's my mistake. I'm going to switch it back to the original. Not having the offset in there tricked me for a moment. We're good with that. The spacer, I'm just going to eye-mate that into place here. Now, I know there's no eye-mates on this bearing right here, since it's part of a assembly, but you can see what's happening. Inventor knows that this eye-mate is an insert, and it will try to find other round surfaces that we can match that to. Even though there isn't an eye-mate there, it will let me eye-mate to it. There's that to that. There's that spacer's now attached. The shaft collar goes around the back side. Got to tilt my angle, can't see the shaft. Now there is not an eye-mate on this side, and there is no round surface against the metal there. So this will require a couple of constraints. We're going to mate to the curved surface on the inside of the bearing flat. That will line it up on axis. Now I'm going to pick the multi-undirected solution here. That'll let that piece flip around if I need it. Now it happened to place it on this side. I'm going to swing it back over so you can see what's up. Tilt up. And since I let it be the undirected solution, when I mate this side to this side, it is actually able to flip it around. And I don't have to change my view and select the harder to find two sides that are actually facing. I'm going to apply this, do a little angle constraint on the bolt and the side of the shaft. Okay, at this point I'm ready to bring the arm into place. So that is up on a V5 Clawbot folder. It was the arm segment bottom. Bring that in, place it nearby. Let's see here. Now I do need an insert constraint on that. So insert, grab this curved edge there, and just match it up with the edge of the spacer. There you go. Now, it doesn't rotate with the shaft, which will be an issue. So how are we going to get in there to the gear? Well, if you remember, we've done this before. We go to free move, temporarily move the gear out of the way so that I can see the insides here. There we go. And then I'm just going to do an angle constraint between one of the flat edges inside of there with one of the flat edges of the axle, I don't care which one, and that should lock it up so that they turn with the axle. Okay. Finally, we need another spacer on this side. I'll just copy one out from my model browser. It's the 1/8 inch spacer we just used. No eye-mate on this assembly, so I will constrain it with a mate constraint, center line to anything that shares that center line. I'm just going to go to, I get a round surface right here. I'm going to click that option. We are going to accept it, and I'm going to drag it back out and constrain the surfaces together with a mate constraint that says that surface needs to push in against that surface. Take a look at what we have. There we go. Can move up and down. Peeking back at the instructions, we can see that I need a spacer, a gear, a spacer, the top part of the arm so that the C channel opens up, and another spacer. I'm going to pull a spacer out from my model browser. Now I have an iMate on the spacer, and that will match up with an inferred iMate on that curved surface. Now I need to bring out the top arm segment. Need to bring out a gear, which is in the motion folder. It's the high strength 12-tooth gear. For the gear, now the iMates on this, if there are any, I believe they're just for the planes. We're not going to use those when we don't have an iMate. Again, we can do an insert constraint. So choose the insert variation, and I need to pick one of these curved edges here that make the circle around the gear, and I'm just going to insert that to here. Going to apply it, and then I'm going to go straight to an angle constraint to match up the gear and lock it onto the axle so that it moves with it. For the arm, I need to, well, actually I need to bring a spacer in before I do the arm. Let's bring another spacer in. I'm going to insert, which is going to be an iMate in this case, to the edge of that. There we go. Now I can bring the arm in. I got to be careful how I do the arm. Remember, it has to face up. So this isn't the side that faces here. I'm going to flip around to this side. I'm going to constrain that flat edge of the C channel to the edge of that spacer. Now, it looks weird. It's not pointing up. It's because it's rotated around the back. When we spin it around to the front, it will be okay. So to spin it around, I need to lock this hole right here on the axle, so the axle goes through there. So constraint, mate. I'm going to pick the center line of one of those two bearings on either side, and the center line of anything that shares the center line of the axis. Spacer is the easiest. Now the solution set that I need, well, you do that one. That one doesn't do anything because it's an invalid solution, or I could pick the one that lets me work with either. Now, when I come off to the side, you can see if this spins around that it is in the proper orientation. All right, to finish this up, I need one more spacer on the outside here. So go back to the browser, find the spacer, pop it out. Again, no iMates on the edge of this assembly, so 2 steps to that. Constrain a mate constraint between that surface of the spacer and that, and then from the center line of this to anything along the center line. There we go. Now in the next video, we'll put the side of the tower on and move into the claw.